The diagram shows the speed time graph of the motion of an athlete in a race. So let me draw this figure. Okay. So this is time in seconds, and this is the speed, meters per second. Okay, so starts at 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So the measure is for 13 seconds. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. So at 1 second the speed is 2 meters per second. At 2 it is 4. At 3 it is 6. At 4 it is 8. Okay. And then at 5 it is 10. Then at 6 it is 12. Okay, this is 12 units. And then all the way up to 10 the speed is maintained. Okay, this 12 meters per second is maintained, and you have a graph in that fashion. Now next the speed is actually decreasing. At 11 the speed becomes 8 units, or I say 8 meters per second. And then at 12 it becomes 4. And at 13 it's hence. Okay. Okay, alright, so that is the graph that has been given to us. Now you have to answer the question. Now I have drawn the graph to explain the question, but there is no need for you to do this. Now, having mentioned that, it is always good to have a rough sketch. You don't have to draw a perfect sketch, but draw a rough sketch so that you can follow and work the question out. Now, first question, they are asking us to find the maximum speed. Okay, now what is the maximum speed? This is time, this is speed. If you see here, this is 10 meters per second and this is 12 meters per second, right? So at this point there is no more acceleration. So this is the spot where the athlete hits the maximum speed. You need to write 12 and make sure to write meters per second. If you don't write the unit, it's wrong. So this is important. Now the next is we need to find the number of seconds find the number of seconds the speed was constant. Okay, I mentioned to you at the start. Now at time 6, the speed is hitting this point. Okay, this is the spot. It is hitting this maximum speed, and the athlete is keeping the maximum speed from time t is equal to 6 to time t is equal to 10 seconds. That is a amazing feat. So the or I would say the speed is constant at t is equal to 10 seconds minus 6, which is equal to 4 seconds. So you need to write the number of seconds for which the speed is constant is equal to 4 seconds. You can just box this. This is the working, this is the conclusion. Now next is they are asking find the total distance. Excuse me. Find the total distance covered by the athlete. Now you see this shape. This shape is a shape of a trapezoid. You have a base 1, base 2, and you have the height. So I'm going to write it down here. Distance covered. Distance covered is nothing but half times base 1 plus base 2 multiplied with height. So half times, we need to know the base, right? So this length is actually stretching to 13. Okay, and this is 4 units in length. So this is going to be 13 plus 4 multiplied with the height. The total height is 12 units. Okay, so this is going to be half times 17 multiplied with 12. 2 divides here 6 times 6 7s are 42. 4 6 1 6 7 8 9 10. 102 meters. That's the answer for the question. Okay, this is the next question. During which time period the speed of the athlete was increasing? Okay, so you go over here and look at the graph. Now this indicates increase in speed. It starts at 0 and it goes all the way to t is equal to 6 seconds. This is 6. Okay, so this is the period in which the speed was increasing. So you need to write that. This is the answer. The athlete's speed was increasing from t is equal to 0 to t is equal to 6. Okay, now that period is actually 6 seconds. Okay, now this is the most important part. Okay, this is the most important part. So you can box this and show to the examiner. Okay, now this is the addition. This is an extra information. So having given that, the next point is we have to find the speed of the athlete when it starts to decrease. Now see the graph. Now the speed of the athlete is constant between t is equal to 6 to t is equal to 10. But from 10 onwards, the speed is actually going down, right, to 13. So we will have to write that. The athlete's speed was decreasing from t is equal to 10 to t is equal to 13. So that period is what? That period is equal to 13 minus 10 is equal to 3 seconds. So you can box this. This is what is required. Okay, so the next is find the period and the acceleration equals 0. That's the next question. Now go to the graph. I mentioned to you this is the constant speed. Constant speed means zero acceleration. So when does it occur? T is equal to 6 to t is equal to 10. Okay, so the acceleration is constant, or acceleration was 0 from t is equal to 6 to t is equal to 10. Okay, and you can simply say from the graph we know. From the graph we know. You can just write that statement because we are doing all this from the graph. So that is the conclusion for this beautiful question. Let's move on to the next one. Now this is part B. A farmer supplies his neighbors with X pumpkins and Y melons daily using the following conditions. Now the first condition is y is greater than or equal to 3. Second condition is y is less than or equal to x, always less than or equal to x. And what is x? X is pumpkin. And what is y? Y is melon, right? So y is always greater than or equal to 3. So minimum value is 3, but it cannot exceed x. This is the third condition. Third condition is the total number of pumpkins and melons must not exceed 12. Question. What are the question? Write the conditions as inequalities. Okay, so total number of pumpkin and the total number of melons cannot exceed 12. So that is the answer for this question. Now next what they are asking us is using a scale of 1 centimeter to represent one pumpkin and scale of 1 centimeter. This is for the x-axis. Scale of 1 cm to represent 1 melon. On the y-axis, draw the lines associated with the inequalities. So x x is pumpkin, it's on the popular x-axis. Okay, so let us draw the axis. So this is going to be my x-axis, and x-axis is pumpkin, right? So you have pumpkin, and y-axis is melon. Okay, so you have this point 0. Now if you see here, y is greater than or equal to 3. So these are the inequalities. Y greater than or equal to 3, meaning y is equal to 3. And then y is always less than or equal to x, meaning y is equal to x. Then x plus y cannot, or I would say x plus y less than or equal to 12. It means x plus y is equal to 12. So these are the straight lines. You will have to draw these straight lines. Okay, now the first one, y is equal to 3. If I were to take this as 1, that's what they are given, 1 unit, 1 centimeter is equal to 1 unit. So this is going to be my line. Okay, this line is y is equal to 3. Next, x plus y is equal to 12. So how are you going to draw this? X plus y is equal to 12. When x is equal to 0, y is equal to 12. When y is equal to 0, x is equal to 12. So if I were to take this as 1, 2, 3, 4, so let me mark it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 3 units, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So this is y-axis. So this is the point and this is the point. So we will have to connect these 2 points. Okay, that's the graph there. Next we will have to draw y is equal to x. Now this is critical. So y is equal to x. If I were to put y is equal to x, in x positive y is equal to 12, then you have x plus x is equal to 12, 2x is equal to 12, then x is equal to 12 over 2, so x is equal to 6. So when x is equal to 6, y is equal to 6. So there is an intersection at 6, 6. So there is an intersection here, okay, at this particular point. So what I wish to do is I have put this as 3. So this intersection across should be 6. So if I were to take this as 4, 5, 6, graph is not to scale, okay? Graph is not to scale because I'm drawing it in freehand. So 4, 5, 6, 3, 4, 5 and 6. So this point has to hit the intersection, okay? So that is the intersecting point there, 3, 4, 5, 6. Okay, you don't have to draw it, but I'm just showing it. That is the intersection point. So y is equal to x will be passing through this. Y is equal to this point 6, 6. Okay, so you don't have to draw this line, but this line I've just indicated just to help to draw the line. So y is equal to x is this, and this line is x plus y is equal to 12. Okay, so that is the completion of this graph. Now, so we have the following lines. So this is line 1, line 2 and line 3. So 3 inequalities are guided by these 3 lines. Okay, so now we will have to actually shade the region. So next question they are asking us is shade the region. So this is a question. Let me find the region that satisfies the inequalities. Okay, now y, the first inequality is y is less than equal to x. So y is less than equal to x means this region. Next, x positive y is less than equal to 12. X positive y less than equal to 12 means this region. And then y is greater than equal to 3. Y is greater than equal to 3 is this region. So if I were to start shading this for the first one, shading this for the second one, and then for the third one. So this is the required region. Okay, so that's a lovely question. So next is we will have to, let me write the question down. Determine from your graph the minimum values of x and y that satisfy the condition. Okay, so we need to determine the values of x, y that satisfy the condition. So foremost, we will have to get the points. Okay, we will have to get the points of intersection. Now, we can easily obtain the point of intersection. The intersecting point, one point is 6, 6. Okay, one point is 6, 6. To get the next point, what I'm going to do is, this is the region, x positive y is equal to 12. To get the next point, I'm going to put y is equal to 3, because y is equal to 3 is the line. Okay, so if I put y is equal to 3, I will get x positive 3 is equal to 12. From here, x is equal to 12 negative 3, which means x is equal to 9. So this is the next point. Okay, 9 comma 3. Now we need to take, or we need to get one more point. Now for that point we have to substitute. We put y is equal to 3 in y is equal to x. So in this case y is equal to 3, we substituted in x positive y is equal to 12. For this y is equal to 3, we substitute in y is equal to x. This means we get x is equal to 3. So this is the third point. So what we have to do is we will have to take these points and substitute all these points, because total number of pumpkins and melons should not exceed 12. So we need to substitute it here. Okay, this is the system that we are looking for. So for x is equal to 6, y is equal to 6, you have 12 less than equal to 12. For x is equal to 9, y is equal to 3. Again, all these things will satisfy the system. Okay. So 9 added with 3 is 12 less than equal to 12. Now for x is equal to 3 and y is equal to 3. In this case, we will be getting 3 added with 3, which is equal to 6 less than equal to 12. So this is the minimum value. So therefore the minimum value for x and y that satisfies x positive y less than equal to 12 is x is equal to 3 and y is equal to 3. So that is the solution for this question. Now this question carries 15 marks. Okay, so along with the previous one which I have shown you, so you have to ensure that you are able to get all this. Of course the graph is not to scale. Okay, I'm mentioning it outrightly. The graph is not to scale. The graph is basically meant to show you how the topographical structure is present. You will have to bank your results on the algebra part of it. Okay, because we are drawing it in a free hand, so the structure will be altered. Now, having mentioned that, let me move on to the next question.